Well, hello geometers and seekers of general truths. In this video, I am going to explain how to find the midpoint or to bisect a line segment. And it is to be done to bisect line segment AB. Okay. And big picture, what we're going to do with this is in effect, first make an equilateral triangle using line segment AB. All right, so there I have it. And again, if you don't know how to make an equilateral triangle, look back at one of the earlier notes, the early videos. You have a right triangle using the length ABC. And then we are going to use what we did earlier and bisect angle C. Okay, so we're going to draw a line segment that goes from C down to here, bisecting angle ACB. All right, so now since we have a bisector for angle ACB, what we can do is we can mark the angles. Actually, I should make the name of a point right here. Where the bisector touches AB. Let's call that point D. All right. And what I can say now is that since this angle is bisected, then angle ACD, that's this one, and angle BCD, that's this one over here, they must be congruent to each other. All right. Now, since ACD is equal to BCD, then the two triangles are congruent to each other by side angle side because CD is common between them. And since the two triangles are congruent, then the two line segments AD and BD have to be congruent to each other as well. So as I've said before, I think I'll pause here and then I'll put this image into the notes, and when we can write up all of the explanations. Okay, so again, if you want to watch the animation, go ahead and rewind the video. But I'm going to use this picture here to explain why all of this works, right? So well, what did we do? We wanted to bisect segment AD, so make equilateral triangle. And it's triangle ABC, okay, with length equal to AB. Then two, we're going to bisect angle ACB. Okay. Now, if you look at the picture we have here, the three blue line segments are congruent because they were made to be equilateral triangles. The two smaller angles here, ACD and BCD, they are made to be congruent because we bisected angle ACB. So now we can make this claim here that triangle ACD, that's the one on the left, is congruent to triangle, BCD by side angle side. Okay, so it has the blue side, the angle in the middle, and then the shared red line. So segment AD has to also be congruent to segment BD. Okay. And this again is part of Euclid's proposition on side angle side. This is proposition from book 1, proposition 4, that tells us that, clean this up, proposition 4 that tells us that this particular statement is true. And once we know that AD is equal to BD, then D is definitely the midpoint of that line segment AD. So if we look back at this picture, if I take away all of the stuff that I made before, get rid of all my angles, even getting rid of everything, D here is exactly in the middle of AB. All right, so there you have it, another demonstration on Euclidean geometry. We end every demonstration with the letters Q, E, F. Thus it has been done. Thank you for watching and have a wonderful day.